Hello students, welcome back to the maths class. Today we are going to start exercise 12.2, question number 3rd. This will be a last question of the exercise 12.2, whichever is remaining according to the new syllabus, and then we shall proceed to the solved example. Solved example, whichever are simple for you, that will be given to the homework, and whichever is required to explain, that will be covered in the next and last session of this chapter. So please start preparing for the class test as well. Now see, in the question number 3rd, this question is given to us as one shape of a aeroplane is given to us. Okay, means one picture is given that is in the shape of aeroplane with a colored paper as shown in the figure. Find the total area of the paper used. So the total area is divided into 5 parts. As you can see, the top one is looking as part number 1. The main body of the figure is looking as part number 2, while the two wings are looking as part number 4 and part number 5, and the tail of the figure is looking as a part number 3rd. Okay, so one by one let us proceed to find out all the areas of parts, and then we shall add at the last. So first we shall talk about the first part. So here we will write down area of part 1. Area of part 1, first part. Okay, so in the first part you see what we have given here. See, first part is given as a triangle. Okay, and in this triangle you observe the one side is given as 5 centimeter, while the base you observe, base is not mentioned, but in front of the base, if I look at the bottom, here we have given that 1 centimeter. Okay, so we can say that the base of this figure is also 1 centimeter because both will be same. Okay, so here I can say that this will be also 1 centimeter, one thing. And similarly, observe this triangle is an isosceles triangle. Okay, so if this one is of 5 centimeter, then this side will be also 5 centimeter. So basically we can say that the three sides of the triangle are given as 5, 5 and 1 centimeter. Okay, so let us mention the three sides of the triangle as 5, 5 and 1 centimeter. So first of all we shall mention the sides over here, and then we shall apply the Heron's formula to get the area. So area of part 1, first we shall write down the value of A is equal to 5 centimeter. Similarly, B is equal to 5 centimeter and C is equal to 1 centimeter. Okay, first we shall find out here semi perimeter. S will be equal to A plus B plus C divided by 2. So it can be written as 5 plus 5 plus 1 divided by 2. So basically it will come 11 upon 2. Okay, that will come in fraction. We can't do anything right now here. Okay, so this will be 11 upon 2 centimeter. Now we shall proceed to find out the area. So we can say that therefore area of part 1, first part, that will be equal to under root of, the formula is S into S minus A, S minus B into S minus C. So let us write down the formula first. S into S minus A, S minus B into S minus C. Okay, now further we shall write down the values over here. So if I write down the values, we will make a square root little bigger over here. So values will be here. Yes, so first of all the value of S is 11 upon 2 into the bracket, then this will be 11 upon 2 minus 5, again 11 upon 2 minus 5, and then last it will be 11 upon 2 minus 1 because last value is here 1. Now further we shall subtract first. Okay, so 11 upon 2 will be as it is, 11 upon 2 will be as it is into. Now see, 11 upon 2 minus 5. If I show you in rough how it will come, so see, 11 upon 2 I am writing as it is, while 5 I am writing as 5 upon 1. If I take the LCM, LCM will be equal to 2. Cross multiplication means 11 into 1 11 and 2 into 5 10, means it will remain basically 1 by 2. Okay, so here I will write down 1 by 2 into again 1 by 2 into then 11 by 2 minus 1. If I go in the same manner, it will be 9 by 2. Okay, so now observe here 1 by 2 I can take common 4 times, means I can write down separately 4 times. 11 by 2 I can write down as 11 into 1 by 2. Okay, so basically I am writing in this manner, 11 and 9 I am making a separate pair, while this 1 by 2 I am writing it separately. So how many times I can write down separately 1 by 2 here? 4 times. See, 2 times it is coming 1 by 2. Okay, then 9 by 2 basically it is 9 into 1 by 2. So 9 into 1 by 2, that 1 by 2 I have taken separate, and 9 I am writing with along with 11, where 11 by 2 also I am writing as 1 by 11 into 1 by 2. Okay, so here 2 pair of 1 by 2 is going to form. That 2 pair of 1 by 2 I am taking it outside. So 1 by 2 and 1 by 2, 2 pairs are coming outside, right? And similarly 11 we can keep it as it is, while 9 I can write down 3 into 3. So one more pair of 3 is going to form. So that will go outside. Outside it is 1 by 4. So 3 will multiply with that. So we can say that therefore area of part 1 will be equal to 3 upon 4 under root of 11 centimeter square. Okay, this will be our equation number 1, because in the equation number 1 first part area is coming over there. Okay, now further you see the second part is, we shall find out second part, then we shall go to the part number 4 and 5. Okay, because third part is lengthy, that we will do at last. Now see the second part. Second part you observe it is looking in the shape of rectangle, whereas the length is given 6.5. Please read this figure carefully. Okay, and breadth is given here as 1 centimeter. So we can say that second part is in the shape of rectangle, where length and breadth are clearly mentioned. So we shall find out the area of second part. We shall write down now. Further, yes, now further, wait a minute, yes, now area of part second is equal to length into breadth. Okay, because we can say that since second part is in the shape of rectangle, okay, because it is in the shape of rectangle, therefore we can say that we can apply the formula L into B. Okay, now what is the value of L is given there? 6.5, and the value of B is given there 1. So we can say that therefore area of part 2, second part, okay, you observe the area of second part will be equal to 6.5 centimeter square. This will be our second equation. Okay, now look at the wings, that is part number 4 and 5. So since you know that both the wings are of the same shape and same size, so here to find out the area of one wing, and we can say that the second wing is also same. Okay, observe carefully the part number 5. Part number 5 we have given that the value of the perpendicular wing to the base. Observe the base is given there as 1.5 centimeter and the perpendicular side is given as 6 centimeter. I will show you with the help of one figure what exactly they are giving to us. So if I locate the part number 5, see, first of all we will make one figure here to clarify this figure. So as you can see, I have drawn one triangle over here. So this is perpendicular actually. So base I have taken here as 1 centimeter, okay, and base I have taken here as 1 centimeter, and as you can see the figure, see in this figure you observe this is your perpendicular. Okay, first of all you observe this figure, this is your perpendicular is given to us. This triangle is a right angle triangle. In this triangle we cannot apply the Heron's formula because Heron's formula required all the 3 sides. Okay, so we cannot apply the Heron's formula here. We will apply the area of right angle triangle. Okay, so this one per side is given as 6 centimeter, whichever is making perpendicular, and the another side is given as 1.5 centimeter. So I can say that here the 2 perpendicular sides are given in this right angle triangle. So we can say that one is given as 6 centimeter, sorry, one is given I think 6 centimeter and another one is given 1.5 centimeter. Once we can check, yes, 6 and 1.5. So here I think we need to make corrections. Here this will be 6 centimeter we can say, and the one side I have marked as 1 centimeter, that will be basically 1.5 centimeter. Okay, so this will be 1.5 centimeter. So see this triangle, if I suppose as ABC, so A and B is forming one side and B and C is forming the another side, and B point is common between them. So B is a point of perpendicular. So AB and BC are called as the perpendicular sides, and if you want to find out the area of any right angle triangle, you have to multiply the 2 perpendicular sides and then multiply by 1 by 2. Means we can say that here first we shall give the heading area of part 4 and 5, because both we are finding it together, area of part 4 and 5. So first if we talk about part number 5, so since area of part 5 is equal to area of part 5, as you know that the part 5 is in the shape of right angle triangle, so that formula will be 1 upon 2 into product of perpendicular sides, product of perpendicular side. This is the formula for area of right angle triangle. So who are perpendicular sides here? AB and BC. So that we shall multiply here. So 1 upon 2 into, we can say one side is 6 centimeter and one is 1.5. Now 2 and 6 we can cancel. So this will be equal to 4.5 centimeter square. That will be the area of part 5. We can say that similarly the area of part number 4, similarly area of part 4 would be also equal to 4.5 centimeter square. Okay, so we can write down the combined statement. Therefore area of part 4 as well as part 5, this will be the part number 4, is equal to area of part 5 will be equal to 4.5 centimeter square. So now see, easily we found the area of 4 parts, first, second, fourth and fifth. Okay, now we shall make the we shall find out the area of the part number 5, sorry, part number 3. So that part number 3 is in the shape of trapezium. Okay, as you know that we cannot find out the area of any quadrilateral or a special kind of quadrilateral with the help of Heron's formula. So for finding the area of this quadrilateral, we shall use some other methods. Okay, so let us start. First of all, I will make one trapezium. This is the one side I have drawn. Similarly, we can draw the two unparalleled sides given to us. One more time, same way. Okay, and now we shall draw the base. So here the base I am drawing it. Yes, okay, little bit we need to adjust some part over here. Okay, so see, this is a trapezium given to us. Now in this trapezium, basically what are the given sides? First of all, we shall mark the sides over here. So see, we have given that, observe the trapezium, you can observe the base is given 2 centimeter, rest of all sides are given as 1 centimeter each. So here first we shall mention all the sides. We have given that the base of this trapezium as of 2 centimeter, one thing. Then the second side is given here as 1 centimeter, and these two sides are also given as 1 centimeter each. Now see, this trapezium is basically an isosceles trapezium. Isosceles trapezium means that trapezium whose unparalleled sides are equal. You are seeing the trapezium over here. The name I can give here as P, Q, R and S. So observe here, PQ and RS are looking parallel, while PS and QR are looking unparalleled, but they are equal. So those who are unparalleled sides, if they are equal, such kind of trapezium is called as the isosceles trapezium. And in the isosceles trapezium, if you draw the perpendicular between the two parallel sides, will be always equal, because between the two parallel sides the perpendicular drawn are always equal. That is called as the shortest distance. So here we shall draw the two perpendiculars, one from the point S and second one is the point R. So here I am drawing two perpendiculars first, and now see, our figure is divided into three parts. The two parts are looking in the form of two triangles coming at the end, and in between that one rectangle or square, whichever will be observed afterwards, that is coming over here. So we shall find out the area of these three parts and then we shall get the total area. Okay, so this will be a perpendicular. This is also perpendicular and this one is also perpendicular. Here I am giving the heading area of part third, because that part is remaining here. So area of part number third, that I am finding it now. Now see, first of all, consider an isosceles trapezium. Isosceles trapezium PQRS. Okay, we will say that since here the name is remaining to give, this point we can give M and this point we can give as N. Here we will say that SM is equal to PN. Why? Because PQRS is an isosceles trapezium. Okay, that is the one thing. Now first of all, see, if SM and PN are equal, what will be the value of PM and NQ? Okay, because if that value I need to find out, so you observe the value of MN will be equal to 1 centimeter only, because now SR and MN will be equal. So this will be equal to 1 centimeter. Okay, And one more thing, in triangle, also in triangle SMP and triangle RNQ, SMP and triangle RNQ, observe PS is equal to QR is equal to 1 centimeter. That is the one thing. SM and PN are also equal, because I think SM and RN are equal. So SM is equal to RN, okay, because both are perpendicular. Then similarly we can say that therefore PM is equal to QN. The third side of the triangle will be also equal, okay, because if in a triangle two sides are equal, in two triangles I am talking about, the two pair of the sides are equal, then the third pair will be also equal. So PM and QN will be also equal over here. So see, if PM and QN are equal, how we can get the value? We can say that since PM plus MN plus QN will be equal to 2 centimeter. Okay, that is given to us because if you add all of them, that will be equal to PQ, and value of PQ is equal to 2 centimeter. PM and QN we suppose for some time as x centimeter. So PM if I write down as x, MN is equal to 1 and QN is again x is equal to 2 centimeter. So I can say that 2x will be equal to 1 centimeter, because 1 is going on that side, subtract from 2 it will remain 1. So therefore the value of x is 1 by 2, or you can say 0.5 centimeter. Means the value of PM is equal to QN is equal to 0.5 centimeter. Okay, that is the one thing. Now let us see how we can get the value of SM and RN. Okay, so we shall write down now in right triangle SMP. In a right triangle SMP, observe the triangle SMP once. Okay, because now I am going to apply the Pythagoras theorem to get the value of SM. So see the triangle SMP. Okay, SP will be here hypotenuse, while SM and PM are the perpendicular and the base of the right angle triangle. So we know that here the hypotenuse square will be equal to the square of the other two sides sum. So here we shall write down PS square is equal to SM square plus PM square. Okay, by Pythagoras theorem we can say. Now what is the value of PS? Observe, PS value we have 1 and PM value I have 0.5. SM I am going to find out. So here PS value I am keeping as 1, SM we are finding it, and PM value we have 0.5 square, or you can say that 1 upon 2 square. Okay, so if I write down 1 upon 2 will be more good enough over here. So I will write down as 1 upon 2 whole power 2. So we can say that therefore SM square is equal to 1 minus 1 upon 4, because 1 upon 2 square going on that side becoming 1 upon 4, and from 1 if I subtract it will be 3 upon 4. So I can say that therefore the value of SM will be equal to under root of 3 upon 4, square going on that side becoming square root, so it is 3 upon 4, means it will be equal to under root of 3 upon 2. This will be the value of SM. Okay, now the value of SM we got. So see, easily we can get the area of triangle SMP and the area of triangle RNQ, because SMP and RNQ both are same. Okay, so here we can say that the value of triangle SMP, we can say 1 upon 2 into multiplication of the perpendicular sides that we have applied earlier. Okay, so same formula we shall apply here. So now we shall write down, therefore area of triangle SMP is equal to 1 upon 2 into product of perpendicular sides. Okay, so that will be equal to 1 upon 2 into, what is the perpendicular sides here? One is 3 by 4 and second one is, sorry, under root of 3 by 2. Under root of 3 by 2 and second one is here 1 by 2. Once we can check, see, under root of 3 by 2, the perpendicular I have got it just now, the value of SM. Okay, look at the triangle SMP. So SM we got as root 3 by 2 and PM we got as 1 by 2. Okay, so here we can write down, so this will become here root 3 upon 8 centimeter square. Similarly, now we can find out the area of another triangle, that is another triangle is here triangle RNQ. Okay, so triangle RNQ, if I try to find out, so we can say that similarly area of triangle RNQ is also root 3 upon 8 centimeter square. Now we shall find out the middle one, that is rectangle. Observe, what is the name of that rectangle? SRNM or SMNR. Okay, in that the value of SM is root 3 by 2, that is one side, and second side is 1 centimeter. So we have rectangle here of 1 by root 3 by 2 centimeter. So SMNR, that is our rectangle. So we shall write down at last, and area of rectangle, this question is very lengthy, area of rectangle SMNR is equal to length into breadth. So what is the length we can suppose? That is 1 centimeter, and breadth we can suppose as root 3 by 2. So this will be equal to root 3 upon 2 centimeter square. Okay, now we shall add all these, the area of that two triangles and the rectangle. So we can say that therefore area of part number third part area will be equal to area of triangle SMP, area of triangle SMP plus area of triangle RNQ, okay, and plus area of rectangle SMNR. So area of rectangle, that will be SMNR. Okay, so now further this will be root 3 upon 8 plus again root 3 upon 8 and plus root 3 upon 2. So now if I take the LCM, okay, so 8 will be the LCM here. So we can say that 8, we are taking the LCM, here it will come root of 3 only, here also it will come root of 3, and here it will come 2 4s are 8, so 4 under root of 3. Okay, now if I add 4 root 3, 1 root 3 and 1 root 3. That will be 6 under root of 3. 6 under root of 3 upon 8. So, 2 3 is 6 and 2 4 is 8. So, we can say therefore, the area of part 2, sorry, area of part 3 will be here. Area of part 3 will be equal to 3 under root of 3 upon 4 centimeter square, and this will be, I think, equation number 4th. Okay. So, let us write down the area of whole figure. We can say that therefore, area of whole figure is equal to area of whole figure is equal to area of part 1 plus area of part 2 plus area of part 3 plus area of part 4 and 5. So, area of part 4 and plus area of part 5. Now, see, these many parts we have to add now. Okay. Let us see what is the area of part 1 we have left. See, we will go to the first equation. We shall write down each and every area. Area of part 1, you observe we have 3 upon 4 under root of 11 and second one is 6.5. So, we shall write down first one as 3 upon 4 under root of 11 plus 6.5, that is part number 2. Part number 3 is in front of you, 3 under root of 3 upon 4, and then part 4 and 5 is 4.5, 4.5. Once I will show you, we can check area of part 4 and 5 is 4.5 each. Look at the equation number 3rd, that is 4.5, right. So, here we can say that these many areas we got. Let us add 4.5 plus 4.5, that is 9, and 9 plus 6.5, that will be 15.5. So, this will be 15.5 plus 3 upon 4 if I take common from the two terms, then this will remain under root of 11 plus under root of 3. Now, this you can simplify a little more further and you can get the required answer. So, this complete the question of 12.2. Okay. So, now since today's time is get over, this one question consumed a lot of time. So, we cannot solve the further part. Solved example we shall see in the next session. Okay. Thank you.